Hi, I am Jumaida Rojo and I am here to present to you the performance task of the 6th group, Operations and Composition of Function. First, let us have a brief introduction of our first topic, the operation of functions. So let's have a little recap about the lessons that have discussed in the past lessons. We all know that a function is a relation if each element of our input value is related to only one output value. And just like the numbers and polynomials, we can also add, subtract, multiply, and divide function, which result to a new function. As I have said earlier, functions can be added, subtracted, multiplied, and divided. Definition: let f and g be functions, then, in addition, their sum denoted by quantity of f plus g and is substituted as quantity of f plus g of x is equals to f of x plus g of x. In subtraction, their difference denoted by quantity of f minus g and is substituted as quantity of f minus g of x is equals to f of x minus g of x. In multiplication, their product denoted by quantity of f times g and is substituted as quantity of f times g of x is equals to f of x times g of x. In division, their quotient denoted by quantity of f divided by g and is substituted as quantity of f divided by g of x is equals to f of x divided by g of x. Let us now have our first example. We have here f of x is equals to 2x plus 6 and g of x is equals to x plus 3. Our first operation is addition. Let's find letter A, quantity of f plus g of x. Since we already have the given of f of x and g of x, we're just going to substitute the given. After the substitution, it is now the time that we have to simplify by finding and adding like terms. 2x plus x. Always remember that x has a value of 1, so 2x plus x gives us a sum of 3x. Next, let us add the constant numbers, which is 6 plus 3. That gives us the sum of 9. So, our answer is simply 3x plus 9. For our letter B, our next operation is subtraction. Let's find letter B, quantity of f minus g of x. Here, we have f of x that is equals to 2x plus 6 minus g of x equals x plus 3. Then substitute. We need to multiply our negative sign para mawala ang ating parenthesis. And then we'll have 2x plus 6 minus x minus 3. Then, let's combine like terms. 2x minus negative x is equals to x. 6 minus 3 is equals to 3. So our answer is simply x plus 3. For our letter C, our next operation is multiplication. Let's find letter C, quantity of f times g of x. Again, let us substitute it first. We have here f of x that is equals to 2x plus 6 multiplied to g of x that is equals to x plus 3. Now that we have substituted it, we will now use FOIL method. First, 2x times x is equals to 2x squared plus outer 6 times x is equals to 6x plus inner 6 times x is equals to 6x. And our last is 6 times 3, that is equals to 18. Next, let's combine like terms. We have here 6x plus 6x, that is equals to 12x. And so, our final answer, or our answer is 2x squared plus 12x plus 18x. For our letter D, our next operation is division. Let's find letter D, quantity of f over g of x, wherein g of x is not equals to 0. Let us substitute it first. We have here f of x, that is equals to 2x plus 6 over g of x, that is equals to x plus 3. Now, let's simplify it. 2x plus 6 divided by x plus 3 gives us the quotient of 2. Why is our quotient 2? Let's check if it's correct. 2x divided by x is equals to 2, and 6 divided by 3 is equals to 2. So our answer is correct. Let us now proceed to our second set of example. The given f of x is equals to 2x squared minus 5x minus 12, and g of x is equals to 2x plus 3. Letter A, quantity of f plus g of negative 2 is equals to f of negative 2 plus g of negative 2. The difference between this and the first one is that we have to change the x by the number that is given. So let us start. I'm going to separate the f of x and to the g of x for us to have a clearer explanation and also to avoid being confused. F of negative 2. First, we have to replace all x's with negative 2. So we have here 2x squared minus 5x minus 12. We're going to replace it with negative 2. So it's going to be 2 negative 2 squared minus 5 negative 2 minus 12. Once we are done doing the first step, we can now simplify it. Negative 2 times 2 is 4 minus 5 negative 2 minus 12. 2 times 4 is 8. Negative 5 times negative 2 is positive 10 minus 12. 8 plus 10 minus 12 is equals to 6. So our answer for f of negative 2 is 6. Then we have to do the same in the other side. Our g of negative 2. We have here 2x plus 3. Now, we're going to substitute negative 2. So, we'll have 2 of negative 2 plus 3. Negative 2 times 2 is negative 4 plus 3. Negative 4 plus 3 is equals to negative 1. So our answer for g of negative 2 is negative 1. Now that we have the answers, the last step is to add it. F of negative 2 plus g of negative 2 is equals to 6 plus negative 1, that is equals to 5. Letter B, quantity of f minus g of negative 3 equals f of negative 3 minus g of negative 3. We just have to repeat the same steps, but this time the operation is subtraction. We have to replace all x's with negative 3. For our f of negative 3, we'll have 2x squared minus 5x minus 12 is going to be 2 negative 3 squared minus 5 negative 3 minus 12. Negative 3 times 2 is equals to 9 minus 5 negative 3 minus 12. 9 times 2 is 18. Negative 5 times negative 3 is equals to positive 15 minus 12. 18 plus 15 minus 12 is equals to 21. So our f of negative 3 is 21. For our g of negative 3, we have to multiply the negative sign to our g of x. So that's going to be negative times 2x is equals to negative 2x. Negative times 3 is equals to negative 3. After that, we have to replace the x with negative 3. So we'll have negative 2, negative 3, minus 3. Negative 3 times negative 2 is equals to 6 minus 3. Our g of negative 3 is equals to 3. F of negative 3 minus g of negative 3 is equals to 21 minus 3 is equals to 18. So our f of negative 3 minus g of negative 3 is 18. For our letter C, quantity of f times g of negative 2 is equals to f of negative 2 multiplied by g of negative 2. We have to replace all x's with negative 2 like what we have done in the letter A. Our f of negative 2 is 2x squared minus 5x minus 12. Now let's replace x into negative 2. We'll have 2 negative 2 squared minus 5 negative 2 minus 12. Negative 2 times 2 is 4. Negative 5 times negative 2 is positive 10 minus 12. 4 times 2 is 8 plus 10 minus 12 is equals to 6. So our f of negative 2 is equals to 6. Our g of negative 2 is 2x plus 3. Now let's replace that x into negative 2. So we'll have 2 negative 2 plus 3. 2 times negative 2 is negative 4 plus 3 is equals to negative 1. So our g of negative 2 is equals to negative 1. F of negative 2 multiplied by g of negative 2 is equals to 6 times negative 1. And we have negative 6. Now, let's proceed to our example number 3. Letter A, quantity of f plus g of x is equals to f of x plus g of x. Our f of x is x plus 3 and our g of x is x squared minus 2x plus 3. Now, let's substitute. And then let's add it. X plus 3 plus x squared minus 2x plus 3. Let's combine like terms. We have here x and 2x, that is equals negative 2x, that is equals to negative x. So our answer for letter A is x squared minus x plus 6. Letter B, quantity of f minus g of x is equals to f of x minus g of x. Our f of x is x plus 3 and our g of x is x squared minus 2x plus 3. Now, in subtraction, we need to multiply our negative sign to our g of x. Now, let's substitute it. We have x plus 3. Negative times positive x squared is negative x squared. Negative times negative 2x is equals positive 2x. And negative times positive 3 is negative 3. Now that we have substituted it, let's now subtract it. Oh, let's combine like terms pala muna. We have here 2x and 3. That is equals to 3x. And our answer for letter B is negative x squared plus 3x. Because 3 minus 3 is 0. Letter C, quantity of f times g of x is equals to f of x multiplied to g of x. Our f of x is x plus 3 and our g of x is x squared minus 2x plus 3. Let's use FOIL method. We have here first, x times x squared is equals to x cubed. X times negative 2x is equals to negative 2x squared. X times 3 is equals to positive 3x. 3 times x squared is equals to 3x squared. Three times negative 2x is equals to negative 6x. And 3 times 3 is positive 9. Now, let's combine like terms. We have here 2x and 3x. Negative 2x plus 3x is x squared. So our answer for letter C is x cubed plus x squared minus 3x plus 9. For our letter D, we cannot divide our f of x and g of x because it is not compatible. Therefore, our f of x and g of x will remain. Let's move on to our next topic, composition of function. Composition of functions refers to application of output from one function as input for another function. This means the range y values or output of one function becomes the domain x values or input of the other function. It is written as f composed of g of x is equals to f of g of x. Let us now have our first example. Letter A, f composed of g of x is equals to f of g of x. Given the functions f of x that is equals to 3x plus 7 and g of x that is equals to x squared plus 5, find f composed of g of x. Substitute x with x squared plus 5 in the function f of x is equals to 3x plus 7. We will have 3x squared plus 5 plus 7. Use the distributive property to remove the parentheses. 3 times x squared is equals to 3x squared. 3 times 5 is equals to 15 plus 7. Our answer for letter A is 3x squared plus 22. Letter B, g composed of f of x is equals to g of f of x. Given the functions g of x is equals to x squared plus 5 and f of x is equals to 3x plus 7, find g composed of f of x. Substitute the x with 3x plus 7 in the function g of x is equals to x squared plus 5. Let's use FOIL method. 3x times 3x is equals to 9x squared plus 3x times 7 is equals to 21x. 7 times 3x is equals to 21x. And 7 times 7 is equals to 49. Plus 5. Let's combine like terms. We have here 21x plus 21x is equals to 42x. So our answer for letter B is 9x squared plus 42x plus 54. Letter C, f composed of f of x is equals to f of x. Given the functions f of x is equals to 3x plus 7, find f of x. Substitute x with 3x plus 7 in the function f of x is equals to 3x plus 7. Use the distributive property to remove the parentheses. 3 times 3x is equals to 9x. 3 times 7 is equals to 21 plus 7. Our answer for letter C is 9x plus 28. Letter D, g composed of g of x is equals to g of x. Given the functions g of x is equals to x squared plus 5, find g composed of g of x. Substitute x with x squared plus 5 in the function g of x is equals to x squared plus 5. Apply FOIL method. X squared times x squared is equals to x cubed, x to the fourth power. X squared times 5 is equals to 5x squared. 5 times x squared is equals to 5x squared. 5 times 5 is equals to 25 plus 5. Combine like terms. 5x squared plus 5x squared is equals to 10x squared. 25 plus 5 is equals to 30. So our answer for letter D is x to the fourth power plus 10x squared plus 30. For our example number 2, we have f of x that is equals to 2x plus 1, g of x that is equals to x plus 1, q of x that is equals to x squared minus 2x plus 2, and r of x that is equals to 2x squared plus 1x minus 1. Letter A. F composed of g of x is equals to f of g of x. Given the functions f of x that is equals to 2x plus 1 and g of x that is equals to x plus 1, find f composed of g of x. Substitute x with x plus 1 in the function f of x that is equals to 2x plus 1. We'll have 2x plus 1 plus 1. Use the distributive property to remove the parentheses. 2 times x is equals to 2x. 2 times 1 is equals to 2 plus 1. Our answer for letter A is 2x plus 3. Letter B. Q composed of f of x is equals to q of f of x. Given the functions q of x is equals to x squared minus 2x plus 2 and f of x that is equals to 2x plus 1, find q composed of f of x. Substitute x with 2x plus 1 in the function q of x that is equals to x squared minus 2x plus 2. Use the distributive property to remove the parentheses. 2 times negative 2 times 2x is equals to negative 4x. Negative 2 times 1 is equals to negative 2 plus 2. Apply FOIL method. 2x times 2x is equals to 4x squared. 2x times 1 is equals to 2x. 1 times 2x is equals to 2x. And 1 times 1 is equals to 1. Let's combine like terms. 2x plus 2x is equals to 4x. And our answer is 4x squared plus 4x plus 1 minus 4x minus 2 plus 2. Let's simplify it and we'll have 4x squared plus 1. And that is our answer for letter B. Letter C, f composed of q of x is equals to f of q of x. Given the functions f of x that is equals to 2x plus 1 and q of x that is equals to x squared minus 2x plus 2, find f composed of q of x. Substitute x with x squared minus 2x plus 2 in the function f of x that is equals to 2x plus 1. Use the distributive property to remove the parentheses. We have 2 times x squared is equals to 2x squared. 2 times negative 2x is equals to negative 4x. 2 times 2 is equals to positive 4. Plus 1. Combine like terms. 4 plus 1 is equals to 5. So, our answer for letter C is 2x squared minus 4x plus 5. And lastly, letter D, f composed of r of x is equals to f of r of x. Given the functions f of x that is equals to 2x plus 1 and r of x that is equals to 2x squared plus x minus 1, find f composed of q of x. Substitute x with 2x squared plus x minus 1 in the function f of x that is equals to 2x plus 1. So we have 2x squared plus x plus minus 1 plus 1. Use the distributive property to remove the parentheses. 2 times 2x squared is equals to 4x squared. 2 times x is equals to 2x. And 2 times negative 1 is equals to negative 2 plus 1. Our answer for letter D is 4x squared plus 2x minus 1.